Welcome. In this lecture, I'm going to talk about the empty set, which is a particular set that shows up a lot, so it's worth kind of, even though it's a little bit logically tricky, it's worth spending a little bit of time on. Well, because it's logically tricky, it's worth spending a little bit of time on. So here we go. So the definition. So the empty set which has special notation for it, so it's going to be denoted, and we just write it like this. So it's kind of like a slanted through it, like that. So denoted like that is the set with no elements. Okay, so how could this possibly get tricky? So here we go. Or here are your cautions. So these are your cautions. Okay, so the first one is that when we have the empty set, right? So this is the empty set, but this is not equal what you would get if you have the set that contains the empty set, right? This, because, I know this feels a little funny, but this is not empty, so this set is not empty. Because it contains an element, namely the empty set. Okay? And this does not equal, if I go the set that contains the set that contains the empty set, right? And one way to see that these are not equal is that, right, this contains, so this set does not contain so this set contains the set that contains the empty set, but does not contain the empty set as an element. Right, like looking at this, I mean, I know this feels a little bit strange, but right, there's precisely one element in here, and it's a set that contains the empty set. But there's only one element. That's the only element that's in here, and it doesn't contain actually the empty set also. Okay, here's your second warning, or cautionary tale when it comes to the empty set, which is that the empty set is an element of, right, it's going to be an element of the set that contains the empty set, right? Because, right, do the thing, remove the brackets, and then you see it, right? It's in there, okay? And this is an element of the set, right? This is an the set that contains the empty set is an element of the set that contains the set that contains the empty set, because it contains the set that contains the empty set. Okay, so these are a little bit tricky, but once you kind of get used to it, it's not that bad. It's just you have to keep your logic straight a little bit. So you do want to have, you do kind of want to understand the empty set. Nothing's in it, but it is a set. It's just a set with nothing in it. Okay. So, and this is actually good practice with understanding also the difference between a set that contains an element and a set that contains an element. So, once you get the hang of this, it's not so bad. But it's actually good practice to make sure that you straighten out anywhere you might be confused. Okay, so I hope that made some sense and was a little helpful, and I will see you in the next lecture.